Hello, everybody. Thank you for coming. Welcome to this talk about learnings from building design systems at XING. Briefly about me, I'm Benedikt. You can see a picture. I have a different haircut there. So just for reference, this is the picture I use on social media. You can find me as @Terhechte on Twitter. I do write on adventure.me posts about simple Swift guides and so on. And I'm a iOS developer at XING. Now, XING is a German social network located in Hamburg. We have roughly 60 million users. We have native apps for iOS, Android, and Windows. And we also have, obviously, web and mobile web. I will now give you an elevator pitch, which is like a short, brief agenda what this talk is going to be about. And then we go into the actual talk. So in this talk, I will try to explain what design systems are and what specific problem they're trying to solve. And once I explained the problem and design system, I will showcase how we implemented them at XING into the iOS app to solve the problems we had. And then I show also what kind of learnings we got from that. Then I will talk a bit more about design systems to show how design systems could actually solve these problems we had with our first implementation. And then I will discuss the second implementation of design systems that we have in the XING app. So let's start. In order to understand a solution, you kind of have to understand the problem. So before I can even explain what design systems are, I want to briefly talk about what kind of problems do design systems even solve. And so let's go into the problem definition. Let's try to see what is the problem that we're trying to solve here. So let's say you're building an app. Now, I took just some screenshots from the XING app, but let's imagine you're building a simple app. Here we have a profile, and we have a feed, and we have settings. And then at some point, the product guy comes over, and the app grows. Now you have more screens. You have a bit more stuff here and there, and then the product guy comes over again, and then you have more screens. And product guy comes over again a couple of months later. At some point, your app grows more, you have more screens, and you have more screens. So your app grows, and everything becomes bigger and more. And at some point, like you end up with over 300 screens, which is a lot. And in order to solve that, you run into this feature conundrum, which is as time increases, the number of features in an app increase. Like with more time, you get more features. And that means that the code base, it continues to grow. Like it doesn't go down again. It's not like your product guy at some point comes over and says, so I decided we delete 90% of the features in this app. That's not what's going to happen. Instead, the features and the growth of the app, they scale up. I have a brief overview here. This is Chrome from 2008 and Firefox. And so Chrome grew in terms of lines of code from 500,000 lines of code to 7 million lines of code in the past decade. And this is just an example of what other apps just do as well. Everything just grows. Everything becomes more. And Brad Frost, who is a design system researcher, had this to say: we are tasked with making interfaces for more users in more context, using more platforms on more devices with more screen sizes and more capabilities than ever before. And this certainly hits home. We have Catalyst, we have iPadOS, we have iPhoneOS, we have different devices, different screen sizes, new features coming in, and all this has to be supported, and all this somehow has to be reassembled in the UI. And this leads to entropy, because as our products grow, what happens is that the differences, the visual differences within the different sections in the products, they compound. Because we get different developers, different designers, they each have their own ideas, they each try to develop it in a certain way, and so we get small differences, big differences, but within the same app, things look slightly different and out of place between places. And this is manifestations. So we have first-level manifestations here. The first one is that you get UI and UX variations. They may be small, different margins, for example, but they may be big, where you, for example, have a different like icon or like button in one section of the app compared to another section of the app. We also have the reinvention of the wheel. One team might implement a certain UI pattern, a UI element in a certain way, and another team might implement a very similar UI element in a different way. And now we have the same element twice, developed twice in two different places. And this leads us to second-level manifestations. Because this makes refactoring expensive, this slows down development on the whole app, and this bloats our code. So this certainly is not something that we want or that we need and that we would like to get rid of. Design systems are a solution, a partial solution to a problem like that. And I will first give a very brief overview where I just explain in very general terms what a design system is. And then from there, we will look at an example implementation. So first of all, a design system has goals. The first goal is that it wants to align the UX and the UI across the app so that everything in your app looks the same wherever you are. It also wants to improve the design workflow. One stated goal of design system is that it's easier and faster to develop the design for a new feature or for a new section. Similarly, it also wants to improve the development workflow so that you as a developer can implement a new feature or a new section much faster than you could with traditional means, while keeping the UX and the UI consistent across the app. Finally, it also defines a shared language between UI, UX, and development. And if you ever had a problem discussing with the designer what it actually was that he wanted or trying to figure out what in his design the margins were and the paddings and so on, then this is the goal of design systems is to remove this friction so that it's really easy for you to understand what it is that the designers want. Steve May had this to say about design systems. We are not designing pages or screens. We are designing systems of components. And so components are the basis of a design system. You can see them and understand them like Lego blocks, where you can have just an unsorted array of elements, but if you sort them and if you catalog them, then suddenly you can define different products out of these blocks that all look similar and have the same characteristics and are consistent with each other. So what are these components? What is it that these design systems are made out of? First, we have colors. Then we have fonts, symbols, and views. I will talk about each of them in more detail, but before we do that, I want to quickly mention that when these components are defined, that happens in collaboration between UX, UI, and development. So this is a collaborational effort where development and design works together to define these components to also make sure that they are consistent with what the platform expects, let's say iOS. Also, you develop a shared vocabulary across platforms, so that it's much easier for a designer to express what he wants by using a vocabulary that everybody understands. Finally, these components that we are going to see soon, they are used for all UI development. So the idea is that once you buy into a design system, everything you build in terms of UI will be built out of these components. So there's no escape hatch, so to say. Let's begin with colors. We already heard about colors. It's one of the components that a design system is made out of. And so here we have example code. So we have an enum color here, and it has a case background, it has a case border, a case text. So these are the different colors that we can define. And now this obviously is just an example implementation, but the idea is that you have one place where you define the colors that are used all over your platform, all over your app. Now, obviously, you could just use Apple's colors. Apple does also offer colors. They also have semantic colors now coming with iOS 13. But you want colors that are specific to your company, that are maybe bound to your CI, and you want names that you can exchange with the other platforms maybe, because maybe your design system is cross-platform, and you want to use the same names between Android and iOS. Now, you could obviously go to the Android guys and just force them to use the iOS naming conventions, but I don't think this would work very well. Similarly, we have fonts. Once again, we have an enum. We just define headlines, sublines, text, button large, button small, and they are also reflected with a certain look. Once again, you could also use dynamic type, but then you're also using Apple's conventions and not your own conventions for your own library. So the idea within a design system is that you define your own naming, your own conventions here. Symbols are really just images or icons. So here, again, we are defining a list of symbols that we are using to express what is being used in which places. And it's also important to align on these, because otherwise we come to a situation, as I explained before, where you may have a different like button in different sections in your app, because different designers somehow create slightly different icons. And finally, we have views. Views are a bit more complicated. We take these elements that we had before. We take colors, we take images, we take fonts, and then we compose them into abstractions that are specific for use cases. When you take a UI view, as it happens in UIKit, or a UI button, you are allowed to make a lot of modifications to it and customization. So you can take the button, you can add a border, you can add a background color, you can do whatever you want. With views, the idea is that the abstraction you build only serves a very specific use case. So the first example that you can highlight it here is a profile image view that is initialized with the user, and it can only be used to display a profile image. You can't use it with a product image, you can't use it for something else, because it's initialized with the user. This is a very specific element. Similarly, here we have a button that only has a title and an icon, and the icon is bound to an enum, so you are very limited in what you can do with it. You can also go to even more extreme. You can say, I'm defining a like button view, so this button can only be used for liking. So you have different elements that can be used, but they can't be modified. They can only be used for their intended purpose. On the right side, you see some examples of how this is defined, but this is also much more important because this leads us to documentation. One important element of a design system is that everything that you have is documented properly, because the designer and the developer needs to easily understand how to use this and find examples of how this works together. Finally, a really important element is the so-called single source of truth. If you have a system where colors and fonts and so on are defined, you need one single place where you define the colors and where you define the fonts and where you define your system that generates the rest. If you have multiple places where you define the colors, then somebody might forget updating it. And then at some point, everything is out of sync. And then Android might look different than iOS, or one of your sections might look different. So what you want to do is you want to have one place, and from there, all the rest is generated. What you can do is you can use Sketch or Figma, and then take plugins to export from them into code. You can also define your single source of truth with JSON or XML. Or you can also use code. And there are also existing tools that you can use for design systems that basically give you all this functionality for free. This is fundamentally a decision that your company or you have to take to see where and how do you want to store the truth. Once you have all that in place, we can look to what Airbnb has to say about design systems. They say, a unified design system is essential to building better and faster. Better, because a cohesive experience is more easily understood by our users, and faster, because it gives us a common language to work with. To recap about design systems, what you do is you align over colors, fonts, and views. You have a single source of truth, and you have documentation. And with all that in place, you have the fundamentals to installing a design system in your company. So let's look at an example of how this works. At XING, a couple of years ago, we implemented a design system in 2015. And this one was very limited in flexibility by design. And I will present how the system works so that you can see an implementation of an actual design system. But then I will also show you the learnings of what was good and what was bad about the system. Initially, this is a very classical design system. We had fonts, we have colors, we have symbols. But we also had something we called components. And components need a little bit more explanation. So components are immutable combinations of views. This is one component that we had in our system. This is the smallest entity that a developer or a designer could use to design a page. So the developer or designer could take this and could set the image, he could set the headline, the subtitle, or the text at the bottom. The colors or borders or anything else was not modifiable. You could also not add additional elements to it. You could only use this and change basically the variables in there. Here are a couple more, so some more components from our component system. And just as another example, you could also have button components. They look like that if you want to add a button to something like that. So those were the basic components that we used to build our UI. So how does it work? How do you take these elements and compose them? So the way it works is you want to build a new screen. In this case, it's a group view. So you take a component, you take the one that has an image on the left, it has a title and a subtitle and a button, and you place it. And obviously, you give it the model data. Next. you place another two components. They are the same. They're basically two rows that lead to more information. And then you place another component that is an image and a title and a text and a smaller text. Then a rich text component, and then you place an image component. So by placing these 1, 2, 3, 4, 5, 6 components, you basically build a complete screen. This is really fast because it allows you to just stack stuff beyond each other in a vertical manner, and you're done building your screen. So how does this work in implementation? How do you implement that? So I have a very simple overview of basically how this works. Here we have, first of all, a protocol. It's called Image Title Component Protocol. I will only talk about this one component here and not about the rest we saw to make it easier. So that has two properties, a title and an image. Now I have this image title component that is the actual implementation. So it conforms to, it's a UI view subclass, obviously, and it conforms to image title component protocol. It does have a title that when you set it, updates the internal state in the internal label. It does also have a UI image that when you set it, obviously also updates the internal state in the UI image view. The whole setup of UIKit and so on I will ignore. And then, to remember, we have these types. We have the protocol, and we have the actual implementation. We have a factory. And this factory, when you tell it that you want this image title component back, it gives you, so it instantiates the class, but the return type is only the protocol. So whoever calls this method to receive a component only gets the protocol back. He doesn't know that it's a UI view, so you can't apply any UIKit methods on it because it's not a UI view. I mean, internally it is, but the type is not exposed. And by that, we delimit the usability of this because you can only stack it in a vertical manner because you can't even use it with UIKit. The way you do that is, here we have the group view that we saw earlier. We have a header row. This is the row that displays the image and so on and the button. And then we have a forum row, we have a marketplace row, and we have a row for a user. And these are different components there, user component, chevron component, and so on. And then there's one function that's called whenever the model changes. So whenever the model changes, we get a new model, and we apply that model internally to the various components that we designed and that we put here. So this makes sure that whenever the model changes, the data in the screen is up to date. Finally, we need to compose it. We need to compose these elements together. And there's a function that's being called from the system. It's called layout components. And there, basically, we take our header, then we edit, and then we stack a separator below it, then we stack a forum row below it, and finally, we stack a marketplace row below it. Add another separator and the user row. And by doing it that way, we can build this screen in a mere matter of minutes. So the components are all in place. We can just place them one after the other, and basically the screen is done. So building the screen takes maybe 10 minutes, because after that, everything is in place, and we can rest assured that it's consistent with the rest of the app. The key points of this approach are that we have as little configuration as possible in order to make sure that everything is consistent. If we will allow background colors and border colors and so on, things might look out of place. There's no way to access the individual elements. There's only the component. That is the only thing that's possible to approach. There's also no way to use this with UIKit, because to UIKit, this is just some sort of protocol that is not UIKit compatible. We got a lot of learnings by using this. So first I will talk about the good side, the good things about this approach of using a very restricted design system. This is, as I said before, a very fast design and development workflow. You can start doing it and you have new features, new designs really fast, as long as everything you do is based on these components that we have. This shared language also causes much less iteration. Basically, your designer tells you, I need the component number 4, number 5, and number 6 on one screen, and that's all you need to know to implement the screen. You don't need to ask him, okay, what is the margin here? How much padding do you want to here? Do you want to have here? And does this look good? And do you want this to change? Basically, there's no going back and forth with design anymore. We also have a visual similarity in over 300 screens by using this approach. And visual refactoring becomes much easier. So we also recently implemented the dark mode, and that was really easy because the colors were aligned and everything was aligned, and we could just basically go through the components and make sure that everything looks good. This is much easier to do if you have a system like that. But there were also things that didn't work out so well here. The first one is, and this is the biggest problem with the old system, that it's removing the designers and the developers' agency. As a designer, you feel that you're not allowed to express yourself because you're limited to these components that are given to you by somebody else, and you can't modify them, you can't change it in any way. You're basically getting high-level Lego blocks, and you have to do something with it, but it's not what you want to do. Similarly, as a developer, designers may come over and want something from you and want you to develop something that you can't implement. The system is hampering you from implementing the design that you actually want to implement as a developer. As soon as you go into custom design, where you want to do something that is very specific and has specific animations and so on, since this is not using UI kit externally, it's also very difficult to implement, and this made our users very unhappy, or developers. So the lack of flexibility here was kind of standing in the way. Now, as with many things that are standing in the way, they are usually loopholes. And our developers and designers found a loophole, and this was a Cambrian explosion. What happened was, this lack of configuration led the designers and the developers to propose and implement new components with small changes so it fits with the designs that they had in mind. So over time, we had explosive growth in additional components. Take a look at our design system here. So these are 3 different components. Now, you really have to look hard in order to figure out where the differences are. To me, they look very, very similar. I mean, one of them has a slightly different text color, but that certainly could be developed in a different way. And we had many more examples like that, where the elements, the components, were just too similar. As a result, we went from initially 60 components to 260 components in our system. And this made it really difficult for the designers to actually find anything. So some even gave up and said, I can't find the stuff I want, I just design a new one, because it was too complicated to finding them. So that made the whole system difficult to understand, which led us to do a survey. So we got a developer-designer feedback about the system and got the following feedback aggregated: too slow, too time-consuming, cannot find stuff, and too much hassle. That is not good feedback. In addition to that, we had another problem. Android and web, they had also started developing design systems, which meant that our designers, they ran into an additional overhead because Android used a different system than iOS, used a different system than web, but the designers worked on all 3 systems, so they had to know 3 different naming systems, 3 different design systems, 3 different color systems. That became very weird very quickly. As a solution, we looked into the state of current design systems and started to align the XING design systems into one that was more flexible and also working better on multiple platforms. And for that, we used Atomic Design. Atomic Design is a system by design system researcher Brad Frost. He released it in 2013. It was initially made for web development, but it adapts really easily to other platforms. And I will just give a brief overview into Atomic Design here. There are links at the end, so if you're interested, you can inform yourself in a more detailed manner. Atomic Design cuts and slices design systems and the elements in there into 5 different stages. The first one is atoms. Atoms are the smallest possible entity you can find. These atoms can be combined into so-called molecules. You can see here that Brad Frost used a lot of terminology from biology and chemistry. And then these molecules, they can be combined into so-called organisms. And these organisms, then they can be combined into templates. And once you combine templates with data, you get pages. This might sound a little bit abstract, but I have a very nice example here. Let's take the Instagram app. The atoms are a like button, a comment button, the take a picture button, or the user has so and so many likes label. So these are the simplest elements that you can have. These are the atoms. And then molecules are logical combinations of these atoms that together make up an entity. So as an example here, we have the user row. which is the image of the username, and when this user posted this element. So this is one logical element where these elements together make up a whole. There's also another row that is the one with the like button for the current image and the comment button for the current image and the more button. This once again makes up a logical entity. And if we take these molecules and combine them, we get organisms. And organisms are combinations of molecules that serve a particular function. So in this case, the function is to display an image and allow the users basically to like on it and to comment it and so on. So the function of displaying an image is held by this organism that you can see here. Finally, if we take these organisms and combine them, we get a template. And a template really is like a screen. So basically, this is all the atoms, molecules, and organisms together to build a full screen within our app. Now, if we take this screen and we add the actual data from the server, we get a page. So this is the end result. This is the template applied with all the stuff and the pages. And by using this terminology that we have here, we have a clear separation of concerns of what goes where. We have an understanding of how we can split up our UI components and how we can label them and how we can group them. And this basically is atomic design. Now, there's much more to it, and I won't go into that. I just wanted to tease it here. But fundamentally, if you're interested in that, there's lots of documentation. There's even a free book by Brad Frost about atomic design. For the XING design system version 2, we applied atomic design, but also changed small parts of it to better understand, to better fit for what we are doing at XING with the design system. It features that it works on all platforms, which was important to us. That means it's for web, mobile web, Android, and iOS. We share the same terminology, so all the elements have the same names, the colors are the same. We do, however, have platform-specific changes. So if something is different on iOS than it is on Android, then the iOS-specific way is being used. And some names are also then specific to the platform. So we try to find the middle ground between having something that is shared between all platforms, but also taking into account that platform-specific look and platform-specific patterns are very important. It's obviously, as I said, based on atomic design. And our single source of truth is in Sketch, and from there we have custom tools that export from Sketch into code. This is a page from our definition. So here you can see in the top left basically how a button in our design system is defined with, and how it's built out of different components. The components here are the sizing, the colors, the shape, and so on. So all this together makes up the look of this one element. And on the bottom left, you can see how the sizes influence how the button behaves. And all this information is cataloged and it's aligned, and there's a sketch file that all applies this. And basically, as a developer, we can implement these components once based on these detailed sketch files here, and then they can be leveraged and used everywhere. In code, it kind of looks like this. Now, this is only a simple example. Here at the top row, we have a profile image that can be created for a user with a certain URL and a size. Then we can also apply a badge icon and take one out of many different badge icons. Or if you want to create a badge, we basically just create a badge, again, with a certain style out of a enum, and then we can also set the size. What's interesting here is that the sizing is not random, so we call it t-shirt sizes. So each element has large, extra large, medium, and so on, and these are the sizes you can use. You cannot just use any sizes for your elements. So sizing is also part of the design system. We also have documentation. My good coworker, Richard II, implemented a very nice iOS app that designers and developers can use to browse around and to look at the components and the molecules and try them out in real time to see how they behave and understand how they work. But there's one crucial thing missing here. How do you compose these elements? That is a very tricky question. Do you allow your auto layout? Do you basically allow your designers and developers to just take these atoms or molecules and compose them in any manner? Or maybe do you want to limit the expressiveness, but how much do you want to limit it? What about margins and paddings? How do you make sure that they are used consistently throughout your app? Do you add a linter, or do you encode it in your system? This is really tricky. The initial design system that we used, you may remember, only did vertical stacking. That was really easy, because by that we limited the expressiveness fundamentally, but we were also sure that however people tried to implement a layout, it was always looking good, because there was no way to not make it look good, because there was only one way to do it. Jerry McKees, who's also a design system researcher, has this to say: just because you have a collection of design patterns doesn't mean you have a design system. A system is a framework. It's a rule book. It's what tells you how those patterns work together. And this is a fundamental point. Just defining the elements is not sufficient to make sure that it works correctly. You also have to make sure that they can be used correctly together. So how do you encode these rules? I don't have an answer for this. I only have a couple of proposals of what you can do, because fundamentally this is a decision, if you want to implement a design system, that you have to do yourself. You have to see, do I want something that is very expressive? Do I want to have something that is limited? And how do I want to encode this expressiveness? So the first example is this. It's a layout coordinator. So here we imagine that we have multiple coordinators for different layout structures. So this is a column layout, where you basically can lay out your elements in a columnar fashion. So we create a coordinator, and then we insert a row. Now this row has 4 columns. And in this row, we place a label in the column from 1 to 2, and it's floating left. And here, we place another label in the column 3, and it's floating left again. By using this pattern, you give the developer a bit more flexibility. He can take this, and he can use this to implement designs in a specific way. But if you do that, it's still limited, right? It's still not like the designer and developers are using UIKit. There are still so many things you cannot express with this. There's an interesting approach that you can do, though. And so what you do is, you use something I call the unmanaged layout coordinator. In this way, you basically have an escape hatch. As soon as the developer calls this, he's back in your UIKit land. He can take his elements, he can use auto layout as he wishes, he can do stuff, he can add subviews, and he can build all the things he wants to build within the escape hatch. But afterwards, once the developer uses it, you can go into the code base, and you can search for the unmanaged layout coordinator, for this keyword. And then you can see what kind of layouts are being developed using this. And then you can try to refactor it. You can add functionality to your design system to enable these layouts so that they become managed again. And by that, you have a way to allow your designers and developers to design whatever they want, but still enable you yourself to clean this up in the future and make it simpler in the long run, so that your code base is always easy to refactor. Another option is actually SwiftUI, because when we think about it, SwiftUI excels at composition. Each view could be a component. We have a VStack, a HStack, a ZStack. They're basically made for development and for composition. So let's take a look at this. Here we have a SwiftUI group, and it receives a model. And here we have an environment object that is all the layout rules. And this is basically inherited by the environment. So every view basically also has access to this. So we have a VStack, which is a vertical stack of elements. And the rules come from the spacing comes from our ruling. And then we add a profile component. And then for each group row, we add the row component with a lot of stuff. And then if there's a post, we add a group post component. This is very similar to the group that you saw earlier with the first design system that I implemented, that I showed you. But this just uses Apple's default SwiftUI. So you don't have to invent anything new. You can just use what's there, and you can still make sure that all the rules are mostly employed, for example, by encoding the rules of spacing and so on in the component. With that, I would like to talk about some additional points that I didn't really mention in this general design system discussion. The first one is that if your design system should also encompass state and animation, and with state and animation, I mean state is highlighted state, is tabbed, and so on, and animation is clear, then it's difficult if you want to use, for example, Sketch, because you can't, you can try to encode it in there, but that's tricky, because Sketch is not made for animation. There are other tools that allow you to design components for a design system that take care about state and animation. One example is Luna. It's an open source Mac app from Airbnb that they use as the basis for their design system. You can use that, you can look into it. It's a bit of a design tool, but it's also kind of weird to use. Nevertheless, there are tools, but you just have to look around. Another important part is accessibility. If you start developing a design system, you should do accessibility first, because if you encode it into the components of your system, then the whole rest of your app will gain it for free. So it's a very small additional investment to do accessibility from the start, and the whole app will benefit from it. It's also much easier if you use SwiftUI. Finally, here are a couple of links. Obviously, these slides will be shared. If you want, you can also take a picture if any of this is interesting. So there's the Atomic Design blog by Brad Frost, where he introduces his book. There's also Airbnb, which also have a design system. They write a lot about it. And a couple of other articles that also feature design systems. Finally, if you think, man, I really like to listen to this guy's voice, today is your lucky day, because I have a podcast together with my good coworker, Bas Thomas, where we release a new episode every 2 weeks, where we talk about Swift and SwiftUI and Apple and iOS and so on. That's it, and I think now I would have time for questions.